All right, this is part 3 of our stoichiometry lecture series. Today we're going to look at how we can island hop between any unit given. So if we're given particles of one chemical, we can get to particles or liters or grams of another chemical. It's just simply another conversion factor. Just like in the other lectures, please take a second and copy down this entire example, including the equation. All right, let's take a look at how we're going to solve this problem. Using the equation below, what mass of water in grams will be produced if 39.4 liters of oxygen react at STP? If you recall from Chapter A, STP is standard temperature and pressure, and we need to have our gases at this standard temperature and pressure, which is 0 degrees Celsius and 1 atmosphere of pressure, in order to know that we have 22.4 liters in 1 mole. Take another look at this problem. There are no moles mentioned in this problem. If we, If we take a look at our stoichiometry map here, if no moles are mentioned, then we are starting here somewhere on one of these satellite islands, and we got to get all the way to here, to another satellite island for our other chemical. We still need to get to moles, and we still need the mole ratio using the chemical reaction to get to moles of our second chemical, and then move on. So these are 3-step operations. One of these roads to get to moles, the mole ratio to change the chemical, and then one of these roads, to get to another island. So let's take a look. Here we're given that we have liters of oxygen, and we are asked to find, let me get a color that I want, grams of water. So let's take a look. We're going to go from liters of oxygen to moles of oxygen to moles of water to grams of water. Let's see how we do that. Let me shrink this, Let me shrink this down, out of the way. Okay. So we are starting out with a strategy. We've got liters of oxygen, 2 moles of oxygen. Then we can move to moles of water and then get to grams of water. Oh, that's not going to let me do that. Okay. Grams of water. Each arrow represents a step, okay? Let's look at our known values. Because we're at STP, we have 22.4 liters of oxygen equal to 1 mole of oxygen. Moles to moles requires us to build a mole ratio using the equation. There's a 1 coefficient in front of the oxygen, so 1 mole of oxygen will produce 2 moles of water. Let me make that green. And to get from moles to grams, we need the molar mass off the periodic table. So we know that 1 mole of water is equal to 18.02 grams of water. That's when we add an oxygen and 2 hydrogens together. Now we're ready for our calculation. We always start with our given value and unit. So we're going to start with 39.4 liters of oxygen. Let me move our map out of the way. We want to get rid of liters. So liters of oxygen are going to go on the bottom. And we'll go to moles of oxygen. Then we can get rid of moles of oxygen and get to moles of water. and then moles of water, 2 grams of water. Our numbers follow. We have 22.4 liters in 1 mole of oxygen. 1 mole of oxygen is equal to 2 moles of water. And molar mass is the mass in 1 mole of water. And we have 18.02. So, on our calculators, we take 39.4 divided by 22.4 times 2 times 18.02. And we get 63. The calculator answer is 0.39, but we can only keep 3 sig figs, so we round to 4, 63.4 grams of water. This is how we use all the possible islands on our stoichiometry map. All right, for example 2, please take a moment, copy down the entire example, including the equation. Let's take a look at this problem. The equation below shows the combustion of propane, which is C3H8. What mass of propane will react if 932.4 grams of water are produced? So if we take a look at our stoichiometry map, we're given grams of water, and we need to get grams of propane, mass. So we need to go from grams of water to moles of water to moles of propane, and then moles of propane to grams of propane. Let's do this. All right, let's record that strategy of ours. We are going to start with grams of water, and we got to get to grams of propane. So let's start with our strategy. Grams of water, 2 moles of water. From moles of water, we can go to moles of propane. And from moles of propane, we can get 2 grams of propane. All right, let's see our known values here. We know that there are 18.02 grams of water in 1 mole of water. Let me make that a little smaller for us. Okay. We know that according to our equation, we have 4 moles of water. And to build our mole ratio, we look at the coefficient in front of the propane. There's nothing written, so that's equal to 1 mole of propane, C3H8. Shrink that guy down. And then, using the periodic table and adding 3 carbons and 8 hydrogens, we know that 1 mole of propane is equal to 44.11 grams of propane. I'm going to shrink that guy down. Once we have our 3 equalities for our known values, we're ready to calculate. We always start with our given value in unit. We are starting with 932.4 grams of water. We got to get rid of grams of water and go to moles of water. Then we get rid of moles of water and go to moles of propane. And then we can get rid of moles of propane and get 2 grams of propane. All right, our numbers follow. 18.02 grams of water to 1 mole of water, 4 moles of water to 1 mole of propane, 1 mole of propane to 44.11 grams of propane. Let me shrink this down a little bit. Close that parentheses that I couldn't fit in. Now on our calculator, we take 932.4 divided by 18.02 divided by 4 times 44.11. And when we do this, we get an answer of 570.59 on our calculator, but we can only keep 4 sig figs, so we rounded to 570.6 grams of propane. I hope now it becomes more apparent as to why I make you write the unit and the chemical each step of the way, because we're switching both at this point with the stoichiometry. Have a good evening.